Go.
So first step, this is number 6. First step, we have to find the reactions. We have fixed, hinge, pull node, and then roller. So the distance between the hinge and roller is 12, and the pull node is acting at the center. So we're being cut at this point. So also this going down, this thing is going to support it, so it's going up, and this one's going down. So 8 and this are equal, so 8 divided by 2, so this one's 4 going up, this is 4 going up. So if 4 going up, this one's 4 going down. So if 4 going down, the shear is going 4 going up. So now we have all of reactions. Shear moment diagram. So we're going to have 4 going up is 4. Hinge is going down and going up. They cancel out each other. So we're not going to bother with that. So up to here. A going down, so become negative. And then if we bring it to here, and we go up 4, touch 0. So this one is 12, 6. Here's 4, here's negative 4. So moment diagram. Oh, we have to find a moment at that point. For moment at this point, you just take a moment, because since we know all the reactions already, so we just take a moment at this point. You do the math, you're going to get moment is equal to negative 24 keep per feet. So now, it starts from negative 24, and this is 4 times 12, should be 48. 48 minus 24 is just 24, half. So it should be right here, 24. And it's a rectangle, so it's linear. Perfect. And this one, negative 4 times 6 is negative 24. 24 minus 24, so right here. And set here. So this is your moment diagram. 24, so you put over EI, over EI. Now we have to make this into conjugated beam. Fix become free. Let me just draw this thing. Fix become free. Hinge become a support. Pull nodes, nothing. So internal roller or internal pin, it become a hinge. And free become fixed. This one should be point B. This one is D. This one's E. This one's 8. So now bring the moment diagram to here. So we're gonna have this. Let me see.
So okay.
This is D. This is C. This is B. This is A. So B here, so it's B to D. B to D right here. 24 EI. Negative 24, just 24 EI. Because we're going to do shear and moment, so the size it doesn't matter. Like I told you, after we have the area, this is below the line, so we draw the arrow away from the beam, so it's like this. And this one's on top, so it's going to be like this.
So you, wherever there was a hinge, you convert it into a...
Read the book.
Into a roller?
Read the book. Read the book.
It tells you.
So now, we convert everything. And the question asks to find determine the slope on each side of the hinge. B. So we're gonna determine the shear for this one and the shear for going up, so for this one. And before we do that, since we have a new beam, we have to find all the reactions. Or maybe we can just do. Yeah, maybe we can just do this. So we have to find the reactions. This one is a roller. This one is a hinge. This one is support. To find the reaction at this point, we have to make a cut. Is that how I do it?
So equal the same.
No, it's not. So we make a cut to find the reaction. So we make a cut right here. It's gonna be this, that, that. Hinge, support. We make a cut, so assuming there's a force, a shear. This is 12, 6, 12 and 6. Oh, no. This is 6, this is 6, this is 6. So, six, and 6. This is support. So you want to find the reactions, because we make a cut, you're going to have some shear here, but it doesn't matter. Roller always go up. So we take a moment at this point, we can ignore this shear. So we can find the reaction at this point. So we assume going this way is positive. Sum of moment is equal to 0. And we look at this point, so this area is going down. So it's create this kind of motion, so it's positive. So I have to write 24 EI, because this is only EI. Yeah. Times the length, which is 6, divided by 2. Times, because it's central of this one, it's 1/3, so it's 4 plus 12, 16. That's how I do it. 16. Oh, I have no calculations. So this, and for this one, it's going up, so negative. This one is by. By times 12. And for this one, since they're equal, so we can take the whole thing, and it's pointing up, so it's also negative. Let me go ahead, minus 24 EI times here to here is 6, here to here is 12, so the length is 12. Then divide by 2 because it's a triangle. And the centroid for this one, they're equal, so it's at the center. Pointing up, pointing up. So half of this, so 6. So bring By to this side, become positive. So your By is going to be 72. So now we have By. By is 72. So 72. If this support is 72, hinge. We're looking for the whole picture, so this one is gone. So you have shear. Shear going up, so this is going down, so shear is 72. No.
What?
That's not how we calculate shear. Because 72 is not the only load. So we pick this down. 72 is acting up, and we have this. We need to convert this into point load. I use different color.
So the first picture was that right?
Yeah. We have to convert this into a point load. 24 times, Chris, use your calculator because I didn't do this math. 24 times 6 divided by 2, how much?
72.
72. This one is going up. Take 24 times 12 divided by 2. It should be double, so 144.
Mm-hmm.
So now we have point load, support, point load, hinge, ignore it. So we want to find this shear, so you just add up the force on the y direction. So now let me.
So that's 144.
Yes. Yeah, I mean, forgot the calculation. Just add them up. Going down is 72. Going up 72. You cancel this out. This one is going up, so shear is going down. So 144. And for the moment, find the moment. Yeah. Find the moment. We have this. We want to find the moment for this one. So you assume going this way is positive. Some moment is equal to 0. This one, 72 times, this is a point load, so times distance should be 6 is a quarter, so here to here is 4. 4 plus 12 is 16. 16 times, this is 4, yes. 4, yes. 4, 16, 20. Going this way, so it's positive. This one's going opposite way, so it's going to be minus 72 times 12 plus 4 is 16. And for this one, it's going up that way, so also negative. 144 times half of the distance, so 6 plus 4, 10. And you want to find a movement at this point, going this way, positive, so plus moment. So you want to find moment. Moment is equal to 1152. Same way, like this. 1152. So now we have all the reactions.
M was what? 1152?
So go back to the question. The question asked to find the slope before the hinge, which is right here. You know, slope is shear. For shear, at this point is 0. So you have to cut it before this support. So it's right here, and you want to find it before and after. So this one is also right here, just a little bit after this. So let's do this part first. When you make a cut, you're going to have this. Two, 4 over EI. And you want to find this. V. This one's left side, so like this. This is 6. So how are we going to find the shear? We do the same thing. Find the point load. 6 times 24 divided by 2. So you're going to have 72 EI. If this, because this is a point load, if this is 72 over EI, this should be the same because you don't have one point load and another one. So you want to find this equilibrium. This is equal to this. 72 over EI. That is the slope. VL is equal to 72 over EI. Now from that side, so this side is gone.
Okay. Now
Let me write here. V from the left side is 72 over EI. Now, we're going to find this one. This one's VL, this one's V right. So capital letter. So we make a cut. We ignore that part. Let's see, consider all the loop from this side. So we're going to have this. Over EI. Here's 12, here's 4. So, same thing. We want to find the slope after the hinge B. Slope is shear. So, find the shear for this thing. So, first, you have to convert this into a point load. So, 24 times 12 divided by 2. So, you're going to have a point load at the center going up. What's the answer again? 144, right? Yeah, 144. 144. This one, nothing. So for shear, you just add up the force in the y direction. So assume going up is positive. Shear in the y direction should be equal to 0. So 144 going up, so positive 144. Nothing, nothing, nothing. So we have y directions minus 144 equal to 0. So, oh no, I'm sorry. You're going to find this. I forgot to put this down. VR. V from the right side. So this minus this, 0. So VR, I should put this down. So negative minus VR. So VR, 0. Slope from that side is 0. That means, I think that means when you put the force here, this thing is going to bend because it's far away, so I think it's going to be like that. No, like this. So, if right side is 0, that means they have the same slope. Because before we have this, V left, this was V right, and V right 0. I think what that means is they have the same slope. Because you push this, this is bend. Because it's hinged, this is also bend. So like that. So your answer is for 6. It's this. It's done. Finished.
Is it a question to be
Yeah.
separately?
Mm-hmm.